Planning provides the foundation for a successful aerospace project. But eventually, planning must become engineering. This is where ARP4754B Chapter 4 begins. It describes how aircraft functions are transformed into system requirements, how those requirements are allocated, and how complete aircraft systems are ultimately developed, integrated, and verified. Rather than focusing on individual hardware or software components, Chapter 4 takes a systems engineering perspective. It connects the high-level aircraft objectives with the detailed implementation performed later in the lifecycle. Let's begin by understanding why systems engineering plays such an important role in aircraft development. Modern aircraft contain thousands of interacting components: mechanical systems, electrical systems, avionics, software, hydraulics, and many others. Each discipline may perform its own development activities, but the aircraft must ultimately operate as one integrated system. Systems engineering provides the structure needed to coordinate these activities. It helps ensure that every system contributes correctly to the overall aircraft objectives. To support this process, Chapter 4 defines a structured development lifecycle. Chapter 4 follows the complete systems engineering lifecycle. It begins with the overall development process. Next, aircraft functions are translated into system requirements. Those requirements drive the development of the system architecture. Implementation activities follow. Finally, systems are integrated and verified before completing development. Each activity builds upon the previous one. This structured progression helps manage the complexity of modern aerospace programs. Everything begins with the overall development process. The general development process establishes the overall systems engineering workflow, rather than viewing development as isolated engineering activities. ARP4754B treats it as a connected lifecycle. Information flows from one activity to the next. Requirements evolve into architectures. Architectures evolve into implementations, and completed systems are ultimately verified against their original objectives. This structured flow provides consistency throughout development. The next step focuses on defining exactly what the aircraft must achieve. One of the central activities within Chapter 4 is requirements development. The process begins with aircraft-level objectives. These objectives are translated into aircraft functions. Requirements are then allocated to individual systems. As the requirements become more detailed, engineers develop the system architecture that will satisfy those objectives. This architecture forms the blueprint for later implementation activities. Once the architecture has been established, engineering teams can begin building the system itself. Implementation transforms architectural decisions into real engineering solutions. System elements are developed according to their allocated requirements. Different engineering disciplines contribute their individual expertise. Hardware, software, mechanical systems, electrical systems. Although these activities occur in parallel, they all remain connected through the system architecture established earlier. Eventually, these independently developed elements must operate together as one complete aircraft system. As individual elements are completed, they are gradually integrated into larger systems. Interfaces are exercised. Interactions are evaluated. Verification activities confirm that requirements have been satisfied. The objective is to demonstrate that the complete system behaves as intended. Successful integration is one of the most important milestones in any aerospace development program. By this point, the engineering work defined throughout Chapter 4 has come together into a complete aircraft system. Chapter 4 represents the heart of ARP4754B. Planning established the development framework. Chapter 4 performs the actual systems engineering activities. Later chapters introduce the supporting processes that help manage and verify development. Together, these chapters form a complete development assurance lifecycle. The systems engineering process described here provides the foundation for everything that follows. Let's summarize the key points. Chapter 4 describes the complete aircraft and system development process within ARP4754B. It begins with aircraft functions and requirements, continues through system architecture and implementation, and concludes with system integration and verification. Each activity builds upon the previous one, creating a structured systems engineering process that supports both development assurance and aircraft certification. This chapter forms the technical core of ARP4754B and establishes the engineering workflow used throughout the remainder of the standard. If you want to go beyond this introduction to ARP4754B, we offer comprehensive online training programs on our website. Our self-paced courses explain the complete aircraft and system development lifecycle, development assurance activities, certification concepts, and practical engineering approaches used in real aerospace projects. In addition to ARP4754B, we also provide training on ARP4761A and DO178C. You can find the link in the video description and in the pinned comment below. If you found this video helpful, please consider giving it a like and subscribing to the channel. We regularly publish educational content covering aerospace systems engineering, functional safety, software certification, and other engineering standards. Thank you very much for watching, and we look forward to seeing you in the next video.